Hello there, it's Harry. So I posted a video about 2 weeks ago. It's about using our Shiny app to create AE tables. So people are showing some interest in that. So I want to do a few more videos about our Shiny app. I want to give some details of the app. I also want to discuss how to improve the app. Okay, so let's look at the data sets. Here in the screen, I have a small R program. So let's run this program. So this program is using the Haven package to read the two SAS data sets. We have the ADSL and ADAE. I made up these two data sets. Okay, so let's look at the ADSL. So this dataset has three variables. We have the uSubject ID, we have the TRT01P. So notice that this treatment variable TRT01P takes two values, the placebo and the active. We have a variable safety for the safety flag. Okay, in the ADAE we have 7 variables. We have the uSubject ID. We have the 3 AE terms. We have the preferred term AED-COD. We have the system organ class AE-BOD-SYS. We have the high-level term AE-HLT. And here we have the treatment emergent flag. We have the treatment variable TRT01P, and we have the safety flag. Okay, so let's look at the app. So before we look at the program for this app, I want to run the app and to show you the output. So click on Run App. Okay, so here you see there are 5 tabs here. First one is to upload the ADSL. So let's do that. Okay. Second tab is to upload ADAE. So let's do that. Okay. After we upload these two data sets, we can click on this one level. So we get this one level AE table. It's for the preferred term. We have 3 treatment columns. We have the placebo, we have the active, and then we have a total column. We get the count and the percentage for each treatment. This table is sorted by the descending order in the total column. It's in the footnote right here. Okay, so if we click on the 2 levels, so we get this AE table for system organ class and the preferred term. The system organ class is in light gray, and the preferred term is in white. So we have these 3 treatment columns. This table is sorted by the system organ class and the descending order in the total column. Okay, if we click on the 3 levels, we get this AE table for system organ class, high level term, and the preferred term. The system organ class is in dark gray, the high level term is in light gray, and preferred term is in white. This table is sorted by the system organ class, high level term, and the descending order in the total column. This is explained in the footnote. Okay, so that's the output of this app. So let's see how we did it. Okay, so at the beginning of the program, we load these R packages. We're gonna need the Haven package. That's for reading SAS data. We need the Shiny package, of course. We need the Shiny Themes package. So it's used here. You can choose different theme to so that you get a different look in the output. We need the tidyverse package because we're going to use some functions from the tidyverse package, and we need the GT package. This is used to create a table. Okay, first we put the date in this variable, the date. This is going to be used in the footnote. And then we have this UI part. So if you have worked on the R Shiny app, you know the program has two parts, the UI part and the server part. The UI part determines how the output looks. So here we are creating those tabs. We are using this tab panel. So you can see we have the upload ADSL tab, we have the upload ADAE tab, and we have the 1 level tab, 2 levels tab, and the 3 levels tab. Okay, so let's look at the server part. In the server part, we have return table 1, that's for the AE table with preferred term. We have return table 2 for the AE table with system organ class and preferred term. And we have the return table 3 for the AE table with system organ class, high level term, and preferred term. They are quite similar, so we will only look at the details in return table 1. Okay, so here we are doing this reactive programming. Okay, first we read the ADSL and ADAE. Here we are using this condition. The treatment is placebo, safety flag is Y. We are using this condition to get a subset of the ADSL. We call it ADSL1, and then we created this new treatment variable GRP, and we assign the value GRP1 to this GRP. And next we do the same thing, but for the active treatment. And then we have this ADSL3. The ADSL3 is going to be for the total column. And finally, we have this ADSL4. We combine those 3 ADSL datasets together. Okay, in the next few lines, we are doing something very similar, but we are doing it on the ADAE. So we create 3 ADAE datasets for placebo, for active, and for total, and then we combine it together. We call it ADAE4. So after this, we use this table function to calculate the number of patients in each treatment group. This is going to be used in the column headers. And here we are using the summarize function. So this is from the tidyverse package. First, we use this summarize function, group by GRP. So we are counting the patients with at least 1 TEAE in each treatment group. Next, we are still using the summarize function. We use group by GRP and AEDECOD. So here we are counting the number of patients by treatment group and each preferred term. Okay, so after we did the counting, we need to do a transpose. We are using this spread function to do the transpose because we need those treatment columns here. So A1 is for the subjects with at least 1 TEAE, A3 is for those preferred terms, and we're using this C function here. We keep only 4 variables. Okay, so the term is for the preferred term, GRP1, GRP2, GRP3, that's for the treatment column. Okay, then we combine this A1 and A3 together with the rbind function. Here we're doing a sorting. We're using this order function here. This minus final $GRP3, that means we're sorting the table by descending order in the total column. Okay, after sorting, we have to handle the count and the percentage. So here we are calculating the percentage. So we divide the count by the big N, and we're using the format function to keep only 1 decimal. And here we're using the paste function to combine the count and the percentage. And here we're using the if-else function to handle the case where the count is missing. So if the count is missing, we assign a 0 to it. we're doing is this for 3 treatment groups. So this is for first one is for placebo, this one is for active, this one here is for the total column. Okay, after that we use this C function to keep only 4 variables, and we are ready to use the GT package to do the reporting. So here we have the header, we have the source node, and we have the column labels. So notice that in the column label we also have to specify the value of the treatment. So we have placebo, active, and the total. Okay, and here we are using the render GT function to create the AE table. Okay, so that's the details I want to talk about in this app. The return table 2 and the return table 3 are very similar to the return table 1. We only need to do a little bit more work because we are counting the patients by more terms. Okay, so after reviewing this program, you can notice there is a weakness in this app, and the weakness is that we are specifying the values of the treatment. So we have this TRT01P equal to placebo, we have this TRT01P equal to active. So if we have a new data set and the treatment is not taking these 2 values, this R program will not work. So I'm going to discuss some improvement of this app because we really want to use this app to handle a treatment variable with different values. So I'm going to do that in the next video. Okay, so I hope this video is helpful. I'm going to put the datasets and the R program in my GitHub account, and I'm going to leave a link in the description of this video. So if you think this video is helpful, please give it a thumbs up and consider subscribing. Thank you.